So there are two types of division. There's synthetic and long division. Long division is like rocket science, but once you get it, the pattern, it's not as bad as it looks up front. Up front, it is very overwhelming. And then the way I like to teach it in the box method, which you would have seen last week, a lot of kids either hate it or they grasp it really quickly. If you hate it, I highly recommend hanging in there and coming to tutoring and asking some questions, because once you find the pattern and how it works, it's super easy. And I am not naturally a mathy person, so I'm not even just being the math teacher saying that. Like, it makes it super, super easy. Because if you do long division with a large polynomial, like the actual old school long division with the bar and then it works down half your paper, I would say even my brightest students, and me personally, every time, never fails, you will lose a positive or a negative or an addition or an X or somewhere, just because a fairly small polynomial takes up a lot of paper. And so as you move down the lines, we're not really, really well versed in staying very neat. So you lose stuff. That's the reason I teach the box method for long division. They are both long division, whether you do it in the box or you do it, like I said, with the bar and working straight down. All that being said, today I want to focus on synthetic division, because last semester I focused on long division. And I focused on long division because it will answer all of the questions, versus synthetic will only answer if the denominator is linear, so just an x minus 4, x plus 2, and it doesn't have a GCF. So your leading coefficient would be 1, and it's just a binomial. After that, if they get more fancy and crazier and wilder spun up polynomials, long division is necessary. But lots of the students last semester, when we finished, could sort of long divide and then had no idea about synthetic. And again, you got a 50-50 shot that it might be an easy problem, and synthetic division is very easy once, again, you find the pattern in synthetic division. And then there's, again, like I said, for this unit earlier, synthetic division will answer tons of questions. I mean, it could be just like divide these polynomials along with long division. All division can answer lots of different questions, so it's not a terrible skill to have in your back pocket. So synthetic division uses coefficients, and coefficient, remember, is the number in front of the variable. So whatever number is in front of your letters. Write the coefficients of the polynomial in descending order. This is very important. Very important. Descending, important. All the exciting things around it. So the highest exponent first, and that is standard form for any polynomial anyway. So the highest exponent should always be the first term, and then they should go down in order. And if everyone's not present, then you just skip to the next. And then we'll discuss those guys that are not present in a moment, because it says including all descending powers. So that's even when there are people, so like space holders is what we want to make sure is what this is referring to. And when we do our example problems in a minute, I'll show you. So space holders. So if it had 2x to the third, and then it said minus 3x plus 4. So that's 3, 1, none, and you're missing that x squared. So since you're missing the x squared, you're going to have a space holder in that when you set up your synthetic division. So we're going to bring down the first coefficient. So as we're going to solve it, I'm going to go ahead and work on this guy down here. So we're going to write our coefficients. We have 3, 2, 1, none. So everybody showed up. So 3, it has a coefficient of 1. 4 has our x squared. Negative 5 is x. And then 3. We have to take this guy and solve it, because this is asking. So by dividing by x plus 2, the questions you could answer are, is x plus 2 a factor? Is negative 2 a solution? Is there a remainder? Or, again, what is x cubed plus 4x squared minus 5x plus 3 divided by x plus 2? And then it would be a polynomial that you would have left over, possibly with a remainder or maybe not. So we have to solve this to use synthetic division. So we're not using x plus 2. We're going to do x plus 2 equals 0. And we want to get that x by itself. So we're going to move the 2 over. So x is going to equal a negative 2. That negative 2 is going to go in a box in the front. Then you're going to have your equal to. I always like to put a line like this because the number in that far bottom corner tells us tons of things, okay? And we're going to go back up to our notes in a minute. But this guy, if there's anything here, answers lots of questions. So that splat in this case, now that I did the yellow on there, is very, very, very important. So we're going to bring down the first coefficient. That's the 1, the 4, the -5, and the 3. And then we're going to bring down the 1. First guy always comes down. From here, we are going to multiply. So number 3 in your list of to-dos is going to be multiply. Now hang with me because the first time you see this, and obviously you saw this a little last week, hopefully, but if it didn't stick, this is going to feel weird, but just watch the pattern and then you'll pick it up. So I'm going to take that number, that -2, times the number I brought it down. So that's my multiply. So -2 times 1, and it bounces like a bouncy ball. And that number is going to go in that slot, which is -2 times +1 is what? Yes, ma'am. So that's going to go here. Then you're going to work straight down and add. So that's our number 4. So we're going to add straight down because we need a number in the, what I call down here at the bottom, the basement. So 4 -2 is going to give me a +2. And now we need to do a bounce again. So we're going to take that -2 times 2, which is going to bounce up. And -2 times 2 is going to be a -4. So add straight down. -5 and -4 is going to give me -9. And then again, -2 times -9. Bounce back up is going to give me a +18 because a negative and a negative will give me a +18. And then when I work down, what operation am I going to do going straight down? So we're going to add. So it's going to be 21. Okay, so multiply to bounce, add straight down. So multiply is the bounce, or that's what I like to call it, because I feel like those lines look like a bouncy ball. And then add straight down. Now, what is the blank? The last number. The last number, which is going to be the one I highlighted down in the box, is going to be your remainder. So if you remember long division from back in middle school, when you did use numbers, sometimes you have a remainder and you would just put like remainder with an R and then that number. Same thing here, okay? The other numbers stand for the coefficients of the answer polynomials. So coefficients of the answer polynomials whose greatest exponent or degree is 1 less than the original. So because this was an x cubed function and we took out an x by dividing it out, this is now going to become x squared. So then I know it's 1x squared, and then after x squared is going to be an x, so we're putting them in descending order again, 2, 1, none. And then this 21 could be written in a couple of different ways. You could see it written with R21. R21 over x plus 2. And it can also be, you will see the answer, x squared plus 2x minus 9 plus 21 over x plus 2. Now, do understand this is a fraction, so it's not the whole thing over x plus 2 because you already divide the x plus 2 out of this front part. We just were stuck with the leftover number, 21, that we couldn't divide any further with x plus 2. So that's why that is the remainder. So if it just said divide it and solve, this is your answer. If it said, is x plus 2 a factor? Is it a factor? Our answer would be no. And the reason is because there is a remainder. So if that 21 had been a 0, then it is a factor. So if that 21 had been a 0, then it is a factor. But it is not. It's 21. So it is not a factor. The other question they could ask is -2 a solution? So is -2 a solution? And again, this answer is no, because there is a remainder. If there was a 0 at the end in that last box, then there would be it would be a solution, because it would be, which means it would be a root, an x-intercept, a 0. That means that this graph will pass over that point. It would be a solution. Like if you were to factor it out, like think quadratics, when you factored quadratics and you solve the two factors to find your x-intercepts in math 1 and math 2. Same idea. It's just not as easy as a quadratic. So there's more factors. All right. Second example. This one looks very EOC-like. Like this looks almost exactly like the EOC question that's on the release packet. So and it's just another format that they can write it. So instead of your long polynomial divided by, and they wrote it like a sentence, this is your equation form of the same sentence. So we're dividing by x minus 1. So we want to solve for our x value. So we're going to add 1 to both sides. So our x is going to be a positive 1 in our box. Now we have 3x squared minus 5. X squared is the largest exponent, and it is going to be in the front, so that's perfect. But we have 2 to none, so we're missing that 1. So in that case, it would be 3x squared. We'd put a 0, x minus 5, so space holders. I like to think about picture day. Back in the day when you used to have to get a little card, and I say this like picture day was way back in the day for me. I don't even know if they do this anymore. But when you used to line up from shortest to tallest, maybe, or even alphabetical order, some classes too, along the way. But if somebody was missing, the teacher would step in and hand them a card so you didn't end up with their pictures, and so the names matched the faces when they sent the envelopes back. So same idea. We're like putting someone in that seat to save that seat in case they were to show up later and to make sure our answer is correct. So from there, we're going to take our coefficients, which would be 3, 0, and a -5. And now we're going to synthetically divide. So first number drops down every time. So 1 times 3 bounces. And 1 times 3 is going to give me 3. And then again, what operation do I use when I work straight down? So what am I going to do with this 0 and this 3? Yes, thank you. Yep, you're going to add straight down. And then we're going to take that 1, and again, we're going to bounce. So 1 times 3 again, it just happens to be that they're both 3, is going to give me 3 again. And then straight down, we add. So -5 plus 3 is going to give me a -2. So already we know it's not a factor. X minus 1 is not a factor because there's that -2. So x minus 1, not a factor. X equal to 1 is not a solution. And when I say solution, that also means x-intercept, 0. What else am I thinking? Root is another word they use interchangeably. Root, x-intercept, 0, solution. I think that's all I got right now. So both of those are not a thing. And then your final answer, it was an x squared when we started, so it's going to become just an x. So 3x plus 3, remainder -2 over x minus 1. Or again, it could be written 3x plus 3 minus 2 over x minus 1. And again, that x minus 1 is just with that remainder 2. It's not with the entire equation, and the placement does matter when you write it out. And then especially when you're plugging in the calculators or in Desmos, if it doesn't run under the correct number, your graphs aren't going to match, so it won't work there. The second page, I chose one that I think the process is super simple, but I think it would make you panic because it's huge. There's 6 terms. But don't freak out because it's the same game. So I have 6, 5, 4, 3, 2, 1, none. So everybody did show up. That's perfect. So no need for a space holder. We are going to solve x plus 1. So we're going to get that root. So x equals a -1 because that would move it to the other side. That -1 is what's going to go in our box. And then we want to pull the leading coefficient. So what's the first leading coefficient? Yep, 3. And then we've got a -1. If there's nothing there, remember that's an imaginary 1. 2, 3, -1, -2, -1. We're trying to decide again, this question could be just divide them, do the math, let me see it, or is x plus 1 a factor, or is the root -1. I also will ask, what is the remainder? Which so would be just what is the number in that far corner at that rate. So our first one's going to come down. Always drop the first term. We're going to take that -1 times 3, multiply and bounce. So we get a -3. Straight down, we're going to add. So -1 and -3 gives you a -4. -1 times -4 is going to give me a +4. Again, work straight down and add to be +6. -1 times 6, and we're getting the -1 out here times 6, and that's what goes in the next one. It's going to be a -6. So 3 added to -6 is going to give me a -3. -1 times -3 will bounce up. Give us a +3. Work straight down and add. -1 and +3 is going to give me 2. -1 times 2 is a -2. Work straight down and add. -2 and -2 is going to be a -4. -1 times a -4 gives me a +4. Work straight down and add again, and that's going to give me a 3. So again, it's just a lot longer than the other two, but the process is the same, and you just have to stay committed. So our remainder is 3. Having a remainder means that x plus 1 is a factor or is not a factor. Since there's a remainder, is x plus 1 a factor or not a factor? Yes, not a factor because there is a remainder. Not a solution, or we'll put not a root this time, just to use a different word. Not a root, again, because there is a remainder. So those are answering that question because that 3 is there. And you will run into some that are 0. But if you think about a quadratic, it only has 2 points that it crosses the x-axis. And it doesn't have to cross the x-axis 2 times. It could cross it once or bounce off of it. Or it could never cross it at all, which means there's a lot more where you're not going to have a factor than you will have a factor. So if you all of a sudden are like, man, I keep doing these and none of these give me a 0 remainder, the odds are better that it's going to not be a 0 remainder because there's more combinations that are not factors than are factors. Now, we started at x to the 6th, so I know this is going to be x to the 5th with my first number. Bring down the next one. Below 5 is going to be a 4. Bring down the next one. And that's going to be x to the 3rd. Next one is x squared because that's 5, 4, 3, 2. 1, because there's not an exponent present, minus 4, that's our none, and then +3 over x plus 1. So the big call outs that most students say is you forget your space holders. So making sure everybody's present. So again, this is 6, 5, 4, 3, 2, 1, none. Perfect. If any of these guys had not been present in your exponent, like standard form with exponents decreasing all the way down, you would put a 0 to keep that space open for them. And then multiply to bounce to add is what most students also forget. So this is a multiply. This is an add. And I think that is most of the call outs I've heard in the past. Do you guys have any questions with what we're doing so far, or call outs like you don't know where something came from? Okay. So today you started working on in behavior. In behavior, I don't know why it's hard, but again, it's one of those things that's kind of hard for people for whatever reason. And I don't have a good reason because I've never had anybody say anything besides I don't understand, which is not going to help me help you much. So if you have a reason that you think you get confused, let me know. So leading coefficient is when they are in standard form. So the big call out is it has to be in standard form. That's the highest exponent first, and then in numerical order decreasing down. So descending order of exponents from left to right. So the standard form is 2x cubed minus 5x squared minus 4x plus 7. So looking at that, your leading coefficient is going to be the number in the front. So in this case, that leading coefficient is going to be a positive 2. The degree of the leading term, the term is the whole thing, would be this degree, but you're really focusing on that first term. The leading coefficient is just the number, like the coefficient to the x, not the x, just that number. And then your degree is whatever power it's raised to, or whatever exponent it's raised to. So in this case, that's going to be a 3. Now, factored form is a little different. This is going to be a big player when we start doing multiplicity, writing polynomials, because they'll give you the factors and then you have to multiply them out. They'll give you the roots. You have to switch it to factors and then you multiply them out. So you are going to see this form a lot as well. The idea, though, is if we were to multiply this out, this to the third power would happen 3 times. This is to no power, so it happens 1 time. And then this is to no power, so it happens 1 time. So that's 1, 2, and 5, because 1 plus 1 plus 3 is going to be 5. So our degree is going to be 5. Because there is not a number attached to any of these x's, your highest exponent in the front should be a positive 1. And really, you really just need to decide, is it positive or negative? That's the most important part. And it's going to stay positive because all of these x's are positive. So it won't magically change into a negative x at that point. So leading coefficient, first number, and then your degree is the degree of that first term. So noting the forms, this first guy, this is in standard form because it is in descending order. My degree is a 4 because that's the one in the front, and my leading coefficient is 1/2. So if you already did your work today, we know that in the degree, we're just trying to decide, is it even or is it odd? And for leading coefficient, you're trying to decide, is it positive or negative? So in this case, we have positive and even. Now, the positive controls the right side of the graph. So the right side of the graph. So that's over here. So because it's positive, I know this is going to be going this way on the right-hand side of the graph. Because it's even, that controls the left side of the graph, is your degree. So the left side, even means the same, odd means opposite. In my mind, the word odd just looks like they turned the p's upside down. So that was easy for me to differentiate those two. So even is same, odd is opposite. Since it is an even, that means the left side is going to be going up as well. Lots of fun things can happen in the middle. Right now, we're not focused on that as much, just thinking about end behaviors, because the end is on both sides. So this is our positive infinity of x. This is our negative infinity of x. This is positive infinity y, negative infinity y. I think the format of the answer is part of the things that confuse people, but I did give it to you on these notes where you didn't have to write it out. Typically, you do. And I will say also, I've noticed that when it is a multiple choice question, we read too fast. So this is one of those things you just have to slow down, because they can put x to positive infinity in the second line or in the first. The only order that can't change is whatever goes with the positive in this blank has to stay together. But I could read my first sentence second versus, in this case, it was first, if that makes sense. That first line could be the second line. I don't have to look right first and then left, because x to positive infinity is looking to the right, x to negative infinity is looking to the left. So when I look to the right, my graph is going to positive infinity for y, because f of x is the same thing as y. And they can have it written as f of x, they can have it written as g of x, they can have it written as y. All is correct. It's just stating, if you're looking on the vertical axis, which direction is it going. And so in this case, when I look to the left, it's going up positive. Now, also remember, you always have Desmos. So there's no reason you couldn't go put this equation, 1/2 x to the 4th minus 3x squared minus 7, into Desmos, and then look at the right-hand side of the graph, and then look at the left-hand side of the graph, and pick your correct answer. It is, like, really seriously that simple. The second one, standard form or factored form, as our first question or part of our notes. It is factored because you see the parentheses. If I was to distribute that through, if that helps a little bit, x squared times x is going to be x cubed. X squared times 3x is going to, times 3, I'm sorry, is 3x squared. So this would be standard form. That's our factored form. But as we discussed in the notes above, x squared is 2x's, and then times it by 1x is going to be 3 total. So our degree is going to be 3. The leading coefficient is going to be 1 because there's nothing attached to those x's. And it's positive. And our degree is odd. So remember, even is the same, odd is opposite. Positive looking to the right means it's going to go up. So again, this is going to control the right side of our graph. The leading coefficient decides the very right side. And then your degree decides the left side of the graph. Odd is opposite, so this side of the graph will go down. So x to the positive infinity is looking to the right. And in this case, we're going up. So y will go to positive infinity or increase or be positive. As I look to the left, y is going down, so it's going to go to negative infinity. The portion that you always get to decide are these two. These are always, like when you have to write it yourself, x to the right, x to the left. And you just write it as x to positive infinity. As x to positive infinity, then y goes to. It's sort of your sentence structure. If you want to train yourself to say those words in your head, this is where your choices have to be made. Everything else is like as you see, it's an outline. It's going to be the same every time. Looking at the third one, factored form or standard form. This is standard form because there are no parentheses. Would probably be the easiest way to determine standard form versus factored form. The degree, what is the degree to this equation or this polynomial? So we're looking at this guy. What degree is this raised to? Yes, ma'am. I can zoom in. I'm sorry. Is that better? So the degree is 1. And then our leading coefficient is what? Yes. So then once you've identified that, is the degree even or odd? And 1 is going to be odd. This seems so silly, but I had this conversation way too many times last semester. Even means it's divisible by 2. So if it doesn't, it's not 2, 4, 6, 8, 10, 12, 14, it's odd. And then leading coefficient, positive or negative. This is going to be negative. Remember again, the right-hand side is controlled by the leading coefficient. And since it's negative, this is my right side, it's going to go down. So as I look to the right, it's going to be a negative infinity. It's going to go down. Oops, now I'm not on the screen, sorry. And then your degree controls the left side. It's odd, which means it's going to be the opposite of the right. So that means it's going to go up. So opposite of the right, my left side is going to be positive infinity. So opposite of the negative infinity that was happening on the right-hand side. The next one, standard form or factored form. There are parentheses. So this is going to be factored form. The degree, we have to add these together. So this has a 1 because there's nothing there. This has a degree of 2 to the whole binomial and a degree of 3. So it's going to be a degree of 6. So this is an imaginary 1 because there's nothing there. There's a 2 on the outside of the parentheses. When I multiply those together, if you can remember back to like Fox method or FOIL or any of those things you did in Math 1 and Math 2, that x plus 3 is going to give you a quadratic when you multiply it out. And then if you were to do it 3 times, like the x minus 1, it's going to give you an x cubed as their front term. And then we're just going to combine them all. So then our highest, all right, leading coefficient in the last one, there's 1s in front of all those x's. So it's going to stay 1. It's going to be positive as well because there's not a negative in the front of any of those x's, or not a number that is going to turn those into a negative x cubed. So it's going to be a 1. 3 is odd. Remember, the positive leading coefficient controls the right-hand side of your graph. So since it's positive, it's going to go up. And then the odd means opposite, so it's going to go down to the left because it's opposite of whatever was happening to the right. And then when you're writing your end behavior statement, so as I look to the right, as x moves to the right, then y is going to go up to positive infinity. If it helps you to write up, that's fine. And then as you look to the left, y is going to go down to negative infinity. Now, as I mentioned earlier, and I didn't do it because I was trying not to make us all like nauseous and switching screens around too much. At any point, if you're not certain with what you're doing, go put it in Desmos. In factored form or standard form, it's going to graph exactly the same. And then you'll be looking at a graph. It might have lots of curvy-wurvies on the inside, but your ends, you're looking at the two sides where all of a sudden it just took off. Being that this is a cubic function, it'll do a lot of fun things in there. But it's more or less going to go up, down. So that's 1, 2, 3 directional changes. Because this is a single, like a 1, the one right above it is raised to the 1 power. I didn't draw these very good, but it should have 1 directional change. So it's just a negative line. So negative 5x plus 12, thinking back to like Math 1, just a negative line. X squared, we were right. Oh man, I'm confusing myself. We were right. I was right. The last one I mixed up. Sorry, because we did the math here. Wow, it's a long day, guys. I need more caffeine, obviously. So disregard my change. Our initial was right, and then our last one. This is 6, so it is actually wrong, which is even. And I hope I'm not rocking your world, which means these should go up. And this should go up as well. Yes. And just to make sure you know that we are right. So our last one, that got me all spun up. X plus 2, 3, raised to the second power, times x minus 1 cubed. Whoa, cubed. So you'll see here that it ends going up on the left side and it's up on the right-hand side. For it to be 6, you're going to see 1, 2, 3, 4. This flat line is a change in direction, and then 6. So decrease, increase, decrease, increase, flat line, increase. So directional changes will match the number of degrees, whatever your largest degree is in the front.